Good day, guys, and welcome back. We will do another question on inverse proportional. All right, question number 9. We have this very beautiful question. It says that the resistance of wire R is inversely proportional to the square of the radius of the wire X. Okay, that means the resistance represented by R and the radius of the wire is represented by X. Given that the radius of the wire is decreased by 60%, we are required to calculate the percentage increase in the resistance of the wire. Okay, let's get going. From the first statement, what we have is the R is inversely proportional to the square of the radius of the wire, which is X squared, right? The square of the radius, so you have to square it, no choice. Once we did this, what we have to do, we have to change the proportionality symbol into equal sign. So once we put equal sign, we put k over x squared, and we have to write where k is a constant. This is very important for us to write. Okay, we have to let the examiner, right, to know what we are talking about. What is x? They do not know. All right, so we have to tell them k is a constant. All right, it's compulsory. Now, after that, what are you going to do? Basically, well, nothing much, because they don't give us anything, right? They do not know. We do not know what's the radius. We do not know what's the resistance. So they never give us anything. Then they expect us to do a lot of things. Well, not to worry, okay? If they never give us anything, we're going to give them something, all right? What are we going to give them? We gave them in terms of algebra, obviously. So let R1, the small letter, be the all resistance. Okay, right? Let the small r1 be the all resistance. Okay, and let a1, okay, be the all radius. Okay, simple as that. They never give us, we give them, but must be in terms of algebra. All right, we cannot give any numbers, right? Why we need to have the r1 in a1? Why we need to let the r1 be the all resistance and the a1 be the all radius? Because we have to find our constant term, our k, all right, in terms of r1 and a1. Okay, in terms of the all resistance and the all radius. All right, so that we can find the equation that links the r and x, right, the resistance and the radius of the wire. Okay, therefore your r1, the old resistance, will be equal to your k, the constant term, okay, and of course the square of your a1, which is your old radius of the wire. A1 then squared, don't forget, because this is the square of the x, remember, right, the square of the radius, right? Therefore, with this, I can get my k in terms of the r1 and a1, in terms of the old resistance and the old radius of the wire. Okay, therefore your k will be r1. This one, we square it, will be a1 bracket square. No need to put bracket anymore. Okay, not necessary. All right, therefore that's your k, and we can find the equation that links the r and your x squared, correct? Yeah, which is your k already found to be r1 a1 square. Done deal. This is the beautiful equation that links the r and your x, the resistance and the radius. No need to tell me it's about old and new anymore. Okay, this is the equation that links, right? It links the resistance, okay, and the radius, right, of the wire, right? Radius of the wire. Simple. Okay, this is equation is going to be very important. It's very crucial. All right, so from there we can proceed with our next problem, right? Because they say that they're given that the radius of the wire is decreased by 60%, and we are required to calculate the percentage increase in the resistance of the wire. Okay, the radius increases, the radius decreased, obviously the resistance will increase because they are inversely proportional. Okay, Do take note about that. One increase, the other one will be decreased. Increase and decrease comes together. Inverse proportional. That's the whole idea of inverse proportion, isn't it? All right. So, well, we know that all radius, all right, the all radius is your A1, right? We already told that just now. We have already written. The all radius is your A1. All radius will always be, in terms of percentage, will be 100%. And this radius is reduced by 60%, correct? It's decreased by 60%. Yeah, decreased by 60%. So, yep, that means the new radius, right? So let the new radius, right, will be A2. Okay, that let it be what in A2, and it will be only 40%. How you get 40% is 100% minus the 60%. That's why I can get your 40% here. That means the new radius is only 40%, right? Because decreased by 60, right? That means my A2 in terms of A1, right? My A2 in terms of my A1 will be 40% divided by 100% multiplied by A1. All right, 40% divided by 100% multiplied by A1. All right, obviously percentage and percentage can cancel off, 0 cancel off. So 4 divided by 10 will be 0.4 A1. That will be my new radius, right? It's important that we have to write in terms of A1, right? Later we see. Right, I'll prove to you. Don't worry. Now, since we know the new radius, right? Obviously, we can get the new resistance, right? So let new resistance, right? Let the new resistance be R2. Okay. So R2, using our equation that links the resistance and the radius, right? Remember your value, the equation is R1 A1 square divided by X square, right? So, okay, we put back our K, constant term is R1 A1 square, and your new, the radius will be A2, isn't it? Yeah, A2 bracket squared, obviously, right? And of course, we are not going to put A2 here because it will be useless. We have to use our A2 in terms of A1. You know why? You can see now. The numerator is R1 A1 square. This one is 0.481 bracket square. Remember, A2 is equal to 0.4 A1 square, right? So 0.4 bracket square, you get your A2, right? So what we have is your R1 A1 square, your 0.4 bracket square is 0.16 A1 squared. You can see the A1 squared and A1 squared can be cancelled off. What you have is R over 0.16, which is equal to, well, if let's say you do not know how to find, basically it means that 1 divided by 0.16 multiplied by R. Okay, R1, by the way, sorry. Okay, therefore what you have is, you divide 1 divided by 0.16, you get 6.25 R1. This is your new resistance R2 in terms of R1. Cool, huh? That means, remember our old resistance is R1. Okay, our old resistance is R1. All always be in terms of 100%, right? And the new resistance, right? New resistance R2, isn't it? Yeah, new resistance R2, which is equal to 6.25 R1, right? We can get a percentage, of course, but do we need this? We do not need, because we need to know the increase, correct? Yeah, increase or the difference. In this case, it will be an increase because your new resistance 6.25, your old is only R1, 6.25 R1, and All is R1. So there will be an increase of how much? 6.25 R1 minus R1. That will give you 5.25 R1, right? And of course, we can get that also in terms of percentage. This is the one that we want, yeah? The percentage increase, right? So therefore, the percentage increase will be equal to, well, 5.25 R1, right? Divide by R1 here, okay? Multiplied by 100%. We will get the percentage increase, right? So R1 and R cancel off. 5.25 multiplied by 500, obviously it will be 525%. That's it, the end. Okay, simple. All right, thank you guys. Thank you for watching. Have a nice day. Take care. Bye bye.